Okay, good morning, everyone. So, yep, I'm Douglas Hill, and just to clarify things up front. So, what do I mean by keyboard control? So, not like just typing out text, but you can do a lot more with a keyboard, like navigating around apps and the operating system and performing actions. And Apple has been heavily marketing the smart keyboard as an accessory for use with the iPad since the iPad Pro came out in 2015. And last year, support for the smart keyboard extended to the lower-end iPad. So in fact, now in the current lineup, every device except the iPad mini supports the smart keyboard. So Apple is really pushing hardware keyboards for use with iPad. So I think it's reasonable for users to expect to have great keyboard control with iPads. And last October, Apple released Mac Catalyst with Catalina. So this means we can bring our UIKit-based iOS apps to run as Mac apps. And all Macs come with keyboards. So again, users expect great keyboard control, especially since AppKit, which is the more traditional framework for making Mac apps, has really good keyboard support built right into many of the UI components that it provides. However, this unfortunately is not the case with UIKit. And it kind of as a logical consequence of that. As a general rule, iOS apps don't tend to be optimized for keyboard interactions. And like when you're running your UIKit app on the Mac, this can make it kind of feel broken and non-native because kind of standard keyboard interactions don't work. Now this quotation is actually from Apple in their human interface guidelines. It's not that common for them to be so self-critical. And that's what this talk is all about. So after a brief intro, I'm going to cover the API that we can use to add keyboard control in our apps, and then move on to some thoughts on designing a great keyboard user experience. But then most of the time we'll spend looking a bit more depth at the implementation of keyboard control. So just a little bit about me. So I work at PSPDFKit. We are a fully remote and distributed team, and we make a PDF framework on iOS and other platforms. And we showcase the features of our PDF framework in our PDF Viewer app, which has been available on iPad and iPhone for a few years. But in October, alongside Catalyst, we brought it to the Mac. So using Mac Catalyst to take our UIKit code base without having to rewrite everything. And I think at the moment it's quite a powerful productivity app. So it's probably one of the more complex apps built using Mac Catalyst that's out there at the moment. So why is hardware keyboard control useful? Now, I guess you're developers, so you probably have quite keyboard-centric workflows yourself. So I don't think we need to spend much time on this. Like it's just kind of faster if you're typing with the keyboard. Like to reach over to the mouse just to like click one thing, and then you want to go back to the keyboard. That is annoying, and this kind of little cost adds up when you're using apps and your computers throughout the day. And furthermore, so all of that is applicable on an iPad as well. It's also annoying, like reaching over to touch the screen, especially if the iPad is like elevated in a stand, like this fairly hardcore setup. And like that comes into the other benefit, which is ergonomics. Like if you're making some kind of productivity app, people might be using like the iPad for many hours a day. So these improvements make a big difference to neck and back strain. Okay, so the API that we can use. Well, we're going to use the UI KeyCommand class from UIKit. That's like the main entry point to keyboard control. And as of iOS 13, a UI KeyCommand is part of a whole hierarchy of classes which are responsible for menus. And that's both the contextual menus that you get on long press or 3D touch, and also the main menu bar that's shown at the top of the screen on the Mac. So all of these classes derive from UI menu element, which represents anything that could go inside a menu. On the left, you have UI menu, which is a container for other menu elements, and like this is what lets menus be hierarchical. Then in the middle, a UI action performs a closure when it's invoked, and then on the right, the more interesting side for us is a UI command, which calls a selector when it's invoked. And then UI KeyCommand is a specialization of that UI command that can also be triggered by using a hardware keyboard. So you need to know three things to make a UI KeyCommand, and this will come up later on when we look at the implementation. So the title comes from a UI menu element, and this is the user-facing text if that key command was shown in a menu. And then the action, which comes from UI command. So as I said, this is a selector, and this will be passed down the responder chain when the key command is invoked, which I'll get to in more detail in a second. And then the third thing we need to make a key command is obviously what keys need to be pressed to trigger it. So the modifier keys is like shift and command, etc. Then the input is a string representing the main key, which is straightforward for like letters and numbers. It's just like a string containing that character. But for other things like the arrow keys, UIKit defines constants that you can use to detect them. Now, there are other things that UIKit does have constants for, but they're not documented. So this is for things like page up and page down, which are like common on Mac keyboards, not on the laptops, but like an extended keyboard with a desktop. And then there are other kinds of things where like there's no, or at least I don't know any way to detect them using this API, like the function keys, because there's no like input string that would give you a function key. So the responder chain. Now this is the other really important piece of API for working with key commands. So UI responder is the superclass of UI view, UI view controller, and a few other things like UI application. And a UI responder has a next responder property, which is another UI responder. And this forms a chain, which is called the responder chain. And at any point in time, there is a first responder. And the first responder is like the kind of focused UI element. And because it's at the start of the responder chain, it gets the first chance to receive many types of events, including those from hardware keyboards. And then the responder chain typically ends at your app delegate. But the main thing that your app needs to do with the responder chain is at any point determine what the first responder is. So, which means like as the user navigates around your app, you kind of moved what that focused UI element is appropriately. So let's just look at three questions about how we actually use this, these two bits of API, UI key command and the responder chain. So how do we provide key commands to the system? How does the system then like decide which of those key commands are possible at any point in time? And then lastly, how does a key command end up running our code? So you provide key commands to the system on iOS by overriding the KeyCommands method. on UI responder. So this could be in a view or a view controller subclass. And then return an array of key commands. It's pretty straightforward. The other way is this add key command method on UI view controller. Now, what's useful about this is you don't need to subclass anything, so you can you could add this to view controllers that your app doesn't create. Now that was for iOS. On Mac Catalyst, it's a little bit different because of the menu bar. And for that, there's some new API in iOS 13 called the menu builder. So this is how the menu, like the main menu on the Mac, is built, and that is by your app is kind of passed a pre-configured menu structure to which you can like add, modify, or remove menu elements to have the menu end up how you want it. And interestingly, this API is actually available on iOS as well. And the system does call this API, and you can kind of think like this would make sense as a kind of stable and consistent way to expose key commands to the system, because a key command is a menu element, as we saw earlier. However, the system doesn't seem to actually make any use of the objects returned by the menu builder on iOS. So I'm not really sure why it bothers calling it in the first place. So for now, the menu builder is for Mac Catalyst apps, and you should use the key commands override mainly on iOS apps. So yeah, it's a shame that we can't have unified code in this case. So then, like, your app can provide these key commands. How does the system decide what's possible? And this is where the responder chain comes in. So each of your responder objects on the responder chain and will be, like, the key commands method will be called, and then you just combine all those together with anything in the main menu on the Mac, and that is the possible set of commands. Like, for example, in our PDF viewer app, you've got commands from our PDF page view, and then you've got commands from the like the document tab bar at the top, and then commands from the navigation controller. So that's kind of moving along the responder chain, gathering key commands. And then when a key command is like triggered, when the user presses that particular key combination, the system delivers it as a nil targeted action, which means that a second responder chain lookup happens. So the first object going along the responder chain that can handle that action by implementing the method will receive it. So a detail that can be useful here is that the object that provides the key command doesn't necessarily have to be the object that handles the key command, because there's this second lookup on the responder chain. Now, one thing about this API is it's very low level, and UIKit does little else with keyboard support on its own. So this is kind of like if UIKit provided UI gesture recognizer, but didn't build any like higher level functionality like UI button and UI scroll view on top of that makes use of this like touch handling API. I'll talk a little bit about the user experience before going onto the implementation. And I say, like, firstly, look at AppKit as kind of a gold standard, because like Macs have always had keyboards, and the human interface guidelines from the Mac about making use of the keyboard is well worth reading, whether you're making an iOS app or a Mac OS app, because it establishes many useful conventions that are applicable on both platforms. And also, like, look at good Mac apps, see how they're solving similar problems with like similar bits of UI, and how it would make sense to expose that as something that's usable from the keyboard. The next thing would be discoverability. So this kind of follows on from Dave's talk, because when you're using the mouse or the touch screen, like you can have discoverability by having like buttons shown on the screen, but with the keyboard that's not the case, because it's just this like static tray of keys. So the user doesn't know at any point in time what actions it might be possible to take using the keyboard. It's inherently not discoverable. And iOS handles this with this really nice floating panel, which is shown when you hold down the command key on a hardware keyboard. So this just shows all the key commands that are currently possible. And all you need to do to make sure they're included in here is supply a title. But on the Mac, the menu bar fulfills this role exactly as Dave says. And it's not just telling you what commands are possible, but you can see the key equivalents for each one. So you can learn how you can go and get that menu command using the keyboard next time to save time. And so to make the key commands show up here, you need to expose them using the menu builder for Mac Catalyst. The last thing to say about the user experience is be fast and responsive. Now this might sound obvious, but it's important because the benefit of the keyboard is speed. So kind of to make this more concrete, think carefully about whether you want to animate in response to a key press. Because an animation can kind of slow things down, but it also provides the user with important context about if a scrolling animation happens, so they know what actually happened and they don't feel lost. So this would mean if you start an animation in response to a key press, make sure you're not blocking input for your development convenience while the animation is happening, because that could drop subsequent key presses. So here's an example. This is my side project app, which is like a read later app. And it's using a paging scroll view. And I'm going to play a really fast video. This might not be that easy to see, but if you look at the page control circled in red at the bottom, you'll see that as I press the right arrow key 3 times and then the left arrow key 2 times, you'll see that the page control is tracking the correct final state and then ends up correctly 1 page to the right. So this is more work, but not dropping any key presses like that really makes a big difference to the user experience. And I think users notice these kinds of details. All right, the implementations. So I think a naive approach here, that's kind of a simple first pass, would be to look at the content view controllers you have in your app and think what possible actions are there, and then override key commands in the view controller and return them. Obviously, watch out for making a massive view controller, because your view controller already does plenty of things already, I guess. And the other thing is, I think you'll see a lot of repeated patterns across view controllers in your app. So perhaps the code reuse is not going to be that good either with this approach. So what I think works well is to, instead, directly address this limitation that UIKit doesn't provide keyboard support out of the box by building up our own reusable components that do support keyboard interaction. So let's look at some examples. And we'll start with a fairly easy one, which is a tabbed interface. So the standard UI convention is that you can use Command 1, Command 2 to navigate between major sections of an app. And this is exactly what a UI tab bar controller is for. And we have a similar API or similar UI to this in PSPDFKit, where we have this popover with document info, so things like the outline and the list of annotations. And so it's like a tabs at the top UI, and it's not hard-coded which tabs are shown, because the API is flexible. So which of Command 1 and Command 2 shows which content view controller isn't hard-coded. Instead, the container is just looking on demand what the current child view controllers are and creating key commands from that. So let's look at how we can build something like that using a subclass of UI tab bar controller for simplicity. We override the KeyCommands method and call super just in case. And then we map each of the tab bar items to a key command. So as we saw earlier, we need 3 things to make a key command. We can get the title from the tab bar item's title. For the key to press, we can just take the index of each item and add 1, so we get that sequential numbering of the key commands. And then we'll call scroll to numbered tab when the key command is invoked, in which we just need to subtract 1 from the input, which we read back from the sender, and then use that index to set the currently visible tab. So like that's pretty simple, but this is we now have a tab bar controller that is accessible from the keyboard that will work like for any kind of content that you put in it. So it's like a general and reusable solution. Next would be a navigation controller. Because if you think about it, a navigation controller defines a large set of like discrete actions. So it knows whether you can go back based on how many view controllers are in the stack. And it knows what the currently visible view controller is and what its left and right bar button items and toolbar items are. So once again, we can subclass the UI navigation controller and override key commands. We check if it's possible to go back and add a key command for that. And then we want to map each of the currently visible bar button items, whether they're in the navigation bar or the toolbar, into key command objects. So let's look at how we actually do that. How do we do that mapping? So we need those 3 things to make a key command, and we already have the title from the bar button item, or if it doesn't have a title, it at least has an accessibility label, hopefully. It has an action that gets called when it's tapped, so we can reuse that. All that the bar button item is missing is the keys that would need to be pressed to trigger it. So we could add these by making using like a subclass of UI bar button item that has properties for the modifier flags and the input that would trigger it. And we use this in PSPDFKit. So like we provide a lot of like pre-configured bar button items that our customers can like pick and choose which ones they want to show in the UI. And they have like these key equivalents set by default. So they'll have like sensible key commands to invoke them out of the box. Last, I think this is perhaps the most important one, is using like arrow keys to navigate around a UI table view. Because like if you're using an AppKit based app, this is something that just happens with NS table view. But with UIKit, that's not the case. Now we have lists of a lot of different things in PSPDFKit. And this video is almost entirely just using the up and down arrow keys and return to navigate with various lists. You'll see we can't actually interact with UI activity view controller because it runs out of our process, which is annoying, but there you go. But anyway, we got this functionality of using arrow key navigation in all these different screens just by modifying one file, which is our common base table view controller class. And yeah, then this keyboard navigation worked across all of those. So that was nice. How can we do it? Once again, I'll use a subclass for the example. So we can either use UI table view or UI table view controller and override the KeyCommands method. We can add a command to select the item above with the up arrow, select below with the down arrow, and activate the selection with return. Select above and select below just need to decrement or increment the index path, and then programmatically select a row. Now, the key thing here is that a programmatic selection doesn't notify the delegate that that selection happened. So then this can happen in the next step when the return key is pressed. We just call the delegate, and that way it kind of simulates as if the user had tapped that row in the table view. So I apologize for all the heavy use of subclassing. I think it's pretty commonly thought that composition is better than inheritance. So one technique that we can use to alleviate the use of subclasses is, well, I'm calling it responder chain injection. The idea here is that you take your normal flow of the responder chain, and instead of just adding functionality to a view, you can instead create a dedicated key handler object and insert it into the responder chain by changing the view's next responder. And then the key handler's next responder can go back to the view's original next responder. And in this case, in this way, you have a dedicated object that can be just for dealing with keyboard input. And you can kind of keep your view or view controllers with fewer responsibilities, because they probably already have enough responsibilities. At least that's what I found. Now, there's one last nasty detail that I think is very important to know about, and that is the way that a UI key command interacts with text input. So key commands take priority over text input. So this means that while the user is typing in a text field, if some other object on the responder chain is defining a conflicting key command, like an arrow key, instead of moving the insertion point in the text field, it's going to call the action of that key command. This is a useful behavior because you can have something like we have here in PSPDFKit, like navigating a PDF form. You can use the tab key to go between the fields, and it doesn't type a tab character. But the unfortunate side of this is that it kind of defaults to bad behavior. So here's an example of where it's not working so well in Apple's Calendar app. When you're editing an event, if you press Command left, instead of moving the insertion point to the left, it's going to go to the calendar view underneath, drop the popover, and discard any text that you just typed in. Now this is very annoying, and I see kind of similar things to this in other apps, usually less severe, but it's it really disrupts the user when they're just trying to type in some text and then something weird happens. So don't do this to your users, please. The best way I know of to deal with this is to be mindful of whether text input might be active, and to check whether the first responder currently can handle text input by conforming to the UI text input protocol. And then in that case, be more defensive when returning your key commands. So filter out anything that would conflict, like arrow keys, delete, or any letter key without the command modifier. Just don't return those objects in a key commands override. Now this perhaps sounds like kind of a lot of tedious work, like subclassing UIKit components to kind of build up this reusable functionality and dealing with things like text input conflicts and making it fast and responsive by thinking about the animations. Do we all have to implement this in our apps? Well, I thought that was kind of not a very good state of affairs. So I made KeyboardKit, which is available on GitHub now. And it implements a lot of what I've been discussing in this talk. It provides subclasses of many UIKit components to add keyboard control in a reusable way. The user experience is closely modeled on AppKit, so it's designed to be appropriate for Mac Catalyst apps to meet user expectations there. While the public API is based around subclassing, internally it uses this responder chain injection to keep the code structure better. And yeah, it also deals with like the text input conflicts by having like a long list of what commands are used for text input. I wish there was a better way. It also supports the page up, page down, home and end keys. As I said, these are not like publicly documented, but like if you make a Mac Catalyst app and you have scroll views and they don't respond to those, your users will rightly complain because the app feels broken. That's all I have for today. So like, please consider keyboard usability when you're making an iPad or a Mac Catalyst app. KeyboardKit can really help with this, or at least like be an example for the implementation. So on the Mac, this will kind of help you avoid feeling like a non-native app and like a poor platform citizen. And then on the iPad, this is something that it'll make your app stand out as going like above and beyond. And I think like passionate and like kind of pro-level users will really love you for doing that. So thank you very much.
One question. So you see.
Okay, from the top.
No, up to you. You can
Okay.
pick anyone.
Okay, the first question: does UI KeyCommands support detecting events so key being released and being held down? This is a very good question, and unfortunately, the answer is no. UI KeyCommand. So if you think about like pressing a key, it would make sense to have an event when the key goes down and like deliver another event to your app when the key goes up. There is only an event for the key going down. So if you're making a game, you're kind of stuck because you probably want to like hold the arrow key and have like your character continuously move, but there's no way to detect how long the key was held for.
One more. Yeah.
One more, okay. Okay, can a child view controller override the parent's key command or disable certain key commands after it's presented? Well, so the way a child view controller would work is that the child and the parent view controller would both be on the responder chain. So like if the first responder is either that child or a view within the hierarchy of that child view controller, it would be on the responder chain. So this would mean, so for overriding it, yes, you could provide a key command with the same input, and this would mean that the child does handle an input. Although the disadvantage of that is that both of those key commands will be shown in the Discoverability panel, like when the user holds the command key. So that's not ideal because it will show the command from the parent and the child, but like the parent's one's not actually going to get called.
Okay, thanks, Douglas.
I'll still be around for the rest of the conference, so if you have more questions, please come and speak to me.
Okay, thanks, Douglas.